Okay, so we learned how to name the simplest ionic compounds, but there are two additional complications we can have when naming ionic compounds and writing their formulas. So we're going to look at one of those next, and this is called the stock system. We have to use the stock system because some metals can form two or more cations with different charges. This is true for most transition metals. There are some exceptions to this rule, but most transition metals can have more than one charge. It's also true for a couple of p-block metals as well. For instance, tin. Tin can form ions with a charge of +2 or +4, and the same is true for lead, +2 or +4. And in these cases, you must include the ion charge in the name of the metal ion. Otherwise, other people won't know which version of the ion you're talking about. Are you talking about lead 2 or are you talking about lead with a charge of 4? To represent this charge, we're going to use Roman numerals. And we're going to put that Roman numeral in parentheses. And this is what we call the stock system. If you don't know your Roman numerals, then we've got this table here to help you count up to 10 with Roman numerals. And just to give you an example of how this works, there are two versions of copper oxide. So you would never just say copper oxide because you're not giving all the information that's needed. There's copper 2 oxide and copper 1 oxide. Copper 2 oxide has copper with a charge of +2. Copper 1 oxide has copper with a charge of +1. Please notice that the Roman numeral tells you the charge on the ion. It does not tell you anything about the formula. Students often make the mistake where they say, oh, look, there's 1 copper in this formula, so this must be copper 1. That is faulty reasoning. Faulty reasoning. This Roman numeral gives you the charge. So make sure that you're thinking about what that number 2 applies to correctly. When I have copper with a charge of +2, it bonds to oxygen, which has a charge of -2, in a 1-to-1 ratio. When I have copper with a charge of +1 and I have oxygen with a charge of -2, I need 2 coppers for every 1 oxygen. So that's why these formulas look the way they do. But the Roman numeral tells you the charge. So when you are given the formula, you have to figure out the charge of the metal before you can name the compound. Otherwise, you can't name it because you won't know the right Roman numeral. If you have a metal that can only form one type of cation, you don't include the Roman numeral. So this is everything this includes all the examples we did previously. So any metal from group 1, those always have a charge of +1. They don't need a Roman numeral. Anything from group 2 always has a charge of +2. They don't need a Roman numeral. Same thing for group 13. Those are basically always +3. Similarly, there are 3 transition metals that do not form multiple different ions. And those are zinc and cadmium and silver. And those are actually listed on the back of your periodic table. So you don't have to memorize them, but you need to remember to look there to look for them. Zinc and cadmium and silver ions always have these charges as listed. So let's practice naming these compounds. If we have FeCl2, then we know for sure that chlorine always forms ions with a charge of -1. But the iron's charge we don't know. It's one of those transition elements where it could have a variable oxidation state, could have a variable charge. But I can work backwards to figure out what its charge must be. If I have 2 chloride ions, I have a total negative charge of -2. And the total charge here needs to be 0. So working backwards, the charge here must be a charge of +2. Therefore, the name of my formula is iron 2 chloride. That 2 reflects the charge on the iron. With MnO2, I know that I've got 2 oxygen atoms, each with a charge of -2, because oxygen ions always have a charge of -2. But manganese doesn't have a consistent charge, so I've got a question mark there for now. But if I've got 2 -2 charges, that's a total negative charge of -4. So my manganese ion here must have a charge of +4. And therefore my name is manganese 4 oxide. For PbS here, my sulfide ion always has a charge of -2. Therefore, in this case, my lead must have a charge of +2, giving me the name lead 2 sulfide. And for zinc chloride, this is a tricky one. I threw it in there on purpose. Zinc is one of those transition metals that always has a consistent charge. It's always +2. But even if I didn't remember that, I should have known that the charge was +2 because I have 2 chloride ions, each with a charge of -1. But when I name this, I don't use a Roman numeral because zinc always has a charge of +2. So I just still call this zinc chloride. I hope this helped.